Welcome to the lesson today. I'm Siamasaka, Dance. Today we're going to discuss the linear momentum, and in particular we'll look at a question that will enable us to develop concepts in linear momentum. We'll look at really one particular question where we feel the concepts can be developed so that you can apply it to many other questions that can be asked on linear momentum. And so here we go. A ball of mass m moving along the positive x-axis with velocity v(o) strikes a ball with a mass m, which is at rest at the origin. After the collision, the balls move away from the origin. One ball makes an angle of 35 degrees above the negative axis, while the other ball makes an angle of 50 degrees below the negative x-axis. Calculate the velocities of the balls after the collision. And so we have two balls here. This is the first ball, which comes and hits a ball which is at rest with also mass m. The velocity of the ball which strikes the one which is stationary is v(o). And when this one is hit, actually the other ball moves actually 35 degrees above the negative x-axis, while the other one also moves 50 degrees below the negative x-axis with a velocity of v2. And so this is actually a question that I feel will help us to actually develop concepts in solving questions on linear momentum. And so the sum of momentum before the collision, as we are aware, it should be equal to the sum of momentum after the collision. And so, first of all, we look at the sum of momentum in the x-axis before the collision, because this is a two-dimensional question, and therefore we have to break it according to the axis. And so, first of all, we look at the x-axis. So this is before the collision. So the momentum will be mass times v(o), which is the velocity initial. Also, because here, this one is actually along the x-axis, it's not broken into components. So it hits a stationary actually ball, which means that this ball is at rest and it has no velocity. And so the sum of momentum in the y-axis before the collision will be actually be 0 for the first ball as well as the second ball. And so now we look at the sum of momentum after the collision. So after the collision, as I indicated earlier, these two balls separate. The other one separates above the negative x-axis with the velocity v1, and the other one separates with the velocity v2 50 degrees below the negative x-axis. And so if we are to look at the sum of the momentum after the collision in the x-axis, it means that we're going to look at for this ball here, v1, it will be actually v1 cos 35 multiplied by the mass of this ball. And for this other one, it will be v2 cos 50 multiplied by the mass. And this is what we have done here. For the momentum in the y-axis, it will be, for the first ball, it will be V1 sine 35 multiplied by mass. And for this other ball, it will be V2 sine 50 multiplied by mass. But you notice that this ball, with the velocity V2, it is going to have a negative, actually, velocity. And so this is what we have here. And so, according to the principle of momentum, the conservation of linear momentum states that actually the sum of momentum before the collision would be equal to the sum of momentum after the collision. But in our case here, we are looking at in the x-axis. We are saying the sum of the momentum before the collision is supposed to be equal to the sum of momentum after the collision. So you notice that this is the momentum we got before the collision, which was mass of the ball multiplied by its velocity, which is equal to actually the momentum of the ball in the x-axis. Okay, in the x-axis, as we indicated here, it will be V1 cos 35 plus V2 cos 50, and all these multiplied by mass. Okay, so this is what we mean here. And you note that since mass is common everywhere here, it's common here, here, and there, can cancel it out and remain with the velocity initial is equal to velocity 1 cos 35 plus velocity 2 cos 35. Velocity 1 and velocity 2 are the velocities after the collision. Okay, similarly, we do the same to the y-axis. So we get the sum of the momentum in the y-axis before the collision and the sum of momentum after the collision, okay, in the y-axis. And you notice that we said that before the collision, actually, you notice that here, all of them here, there is no momentum in the y-axis. For the first mass as well as the second mass, they do not have momentum in the y-axis, and therefore that one will be actually 0. And as I indicated earlier, the momentum of the balls in the y-axis, it will be V1 sine 35 multiplied by mass, which should be added to actually minus V2 sine 50 multiplied by the mass. And this is what we have actually done here. This is what we have actually done here. And you notice that here, again, mass can be cancelled, remaining with this part here. And so, if you look at the second mass here, since here this side we have 0, we can take V2 sine 50 on the other side, and then this is the equation we're going to have. And then we can easily solve for V2. Sine 35 is 0.574, while sine 50 is 0.766, and therefore we can solve for V. And we find that V2 is equal to 0.749 V1. So it means that we have found actually one velocity here. And so if you go back you want to find the velocity for the first equation. You note that this is what we had here. We said V initial is equal to velocity 1 cos 35 plus velocity 2 cos 50. And therefore, this is now what we have here. And therefore, we can actually find the value of cos 35, which is 0.819, and the value of cos 50, which is 0.643. And therefore, we can now, on this equation, where there is V2 here, we already found the value for V2. So where there is V2 here, we can substitute the value. And this is what we found as velocity number 2, which is 0.749 V1. And so you substitute it here, 0.749 V1 multiplied by 0.643. And meaning that now we can easily multiply these two and add it to V1 0.819. And okay, so this is what you get. V1 is equal to 0.77 V0. So if you are to get the value of actually, so we have found that V1 from here after adding this, we found that V1 is equal to 0.77 V initial, or velocity initial. So if we are to find the value of velocity 2, we can actually, since we found already the velocity 2 here, we can substitute where there is velocity 1 here, we substitute the value which we found here. We said the velocity number 1 is equal to 0.77 V0. So we can substitute it here. Okay, and then you can find the value of velocity number 2, which is 0.580. And so this is the part of the question that I thought we would discuss in order for us to actually develop concepts under linear momentum. I thank you.